Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm Eva Higginbotham, and this week I've been against the clock to get an answer to this question from David.
What method of time would you use in travelling through space as a day, week, month or a year would become meaningless, and how would this affect the body clock?
Our sense of days, nights, weeks and months is so ingrained it's almost hard to imagine. So who better to answer than someone who's experienced space travel firsthand? I put the question to former NASA astronaut Steve Swanson.
What measurement of time would I use if I was on a long space trip? Psychologically, it's best to keep what we're used to in that sense, so you could still celebrate birthdays and stuff like that, because we could then kind of remember how old we are. I think that would be very important to have along too.
Happy birthday!
But what effect might being in space have on your body clock? I asked sleep scientist Cassie Hilditch, who works in collaboration with NASA scientists.
First, we need to understand how our body clock, or circadian rhythm, works. So the timing of many of the processes in our bodies are programmed by a cluster of cells in the brain, and one of their main jobs is to coordinate when our body should be asleep and when we should be awake.
Our internal body clock is set to be about 24 hours, but is usually a little off. This means we need to set our clocks every day to keep in sync with the light-dark cycle of our environment, and our body does that by using sunlight as a time cue. But when our body clock is out of sync, it can affect our ability to sleep, to stay alert, and ultimately lead to long-term health consequences.
On the International Space Station, or ISS, astronauts and cosmonauts are currently having to deal with this very problem. The ISS orbits the Earth about every 90 minutes, so the crew on board see the sunrise and sunset 16 times per Earth day. This, as you can imagine, sends some pretty confusing time cues to the body clock and can cause a disruption of the different systems that are usually synchronized in the body.
On the ISS, there are studies going on trialling the use of specialised lighting to help align the body clocks of astronauts to a 24-hour rhythm by mimicking the light patterns on Earth. If this is successful, Cassie says this technique could possibly be adapted to other spacecraft, including for deep spaceflight in the future.
And we're also starting to think about how we might live on Mars, which has a different day length of 24 hours and 39 minutes. Luckily, this is pretty close to 24 hours, and studies suggest that we might be able to entrain to or synchronize with this Martian day, but we might still need some special lighting to help us.
Thanks, Cassie and Steve. Next week, we'll be taking a cold shower while looking for the answer to this question from Margaret.
Why? I can work in the yard and be covered in sweat for hours and only stink a little, but reveal one sensitive personal thing to a group of friends and immediately stink to high heaven.
So, what do you think? You can email chris@thenakedscientist.com, find us on Facebook, tweet @nakedscientists, or join in the debate on the forum. That's at thenakedscientist.com/forum.